of vibration. Locus of all the particles of the medium which receives light disturbance simultaneously and are in same state of vibration is called as wavefront. Consider plane wavefront AB bounded by rays bounded by rays consider plane wavefront AB bounded by rays PA and PB to be incident on plane reflecting surface XY. The direction of ray of light is also called wave normal. Chota sa definition wave normal, then move ahead. Perpendicular drawn at any point on the surface of wave front. Perpendicular drawn at any point on the surface of wave front is called as wave normal. Remember, it also represents direction of propagation of ray of light. So if they say what is angle between wave normal and ray of light, angle between wave normal and ray of light is nothing but 0 degree because they are in same direction. So consider plane wavefront AB bounded by rays P and QB to be incident on plane reflecting surface XY at an angle of incidence I. So can I say PAL equal to I? Incident ray normal is PAL equal to I. Hello? Hello?
Yes, sir.
So what will be this angle? 90 minus I? That angle, balance one?
Yes.
What will be this angle? I. So angle made by wavefront with the surface is same as angle made by ray of light with the normal. Angle made by ray of light with the normal is angle of incidence, or wavefront with the normal is also angle of incidence. This you have to remember because sometimes they will not say angle of incidence, but it will be given angle made by incident ray with the normal or angle made by wavefront with the surface. Both are same. Just write this wave normal definition and copy this diagram. Then I'm explaining full proof law of reflection wala part. Perpendicular drawn at any point on the surface of wavefront is called as wave normal.
Done, sir.
Okay. Diagram also draw that much. Plane wavefront AB bounded by rays P and QB, incident on plane reflecting surface XY at an angle of incidence I. Done, diagram done, this much.
Yes, sir.
Okay. Now at the instant wavefront reaches A will become secondary source by our Huygens principle and send secondary wavelet in all direction with same velocity but in forward sense. Now can you see when disturbance reaches A, at same time it reaches B also? When it reaches A, at same time it reaches B.
Yes, sir.
So suppose in time t, disturbance from B reaches point C after traveling distance Vc equal to C dash t, because speed is distance upon time. So if C dash is the speed, distance Vc upon time t, Vc will become C dash t. In same time t, secondary wavelet from A will also cover same distance C dash t. So with A as center, BC as radius, we can draw sphere. So this is our wavefront AB. This sends wave, suppose by 10 centimeter, then this will also send 10 centimeter in all direction in same medium. So ये 10 centimeter वाला sphere. Every particle on this, do they get wavefront simultaneously? Hello? Every particle on wavefront, they are getting disturbance simultaneously.
Yes, sir.
So all will send secondary wavelet, which will be same in same time. So if B is sending 10, A is sending 10, this suppose P1, this will also send 10, but it can send only 8 in forward, then 2 will get reflected back. This is sending 7, 3 will get reflected back. So all this sphere cut peak, if I join, this will give me all the wavefront ka reflected wala part. So this part will become reflected plane wavefront because it is locus of all the particle after reflection. Clear? Hello? Hello?
Yes, sir.
If I draw this plane CD, can I say, as by explained by this, every particle on CD, this is my CD, they are nothing but particles receiving disturbance after reflection. Hello? Hello?
Yes, sir.
So CD means which ray? It is reflected plane wavefront. So if you extend this AD and draw parallel to AD here, then I can say that AD is nothing but reflected wave DS and CR. So CD represents reflected plane wavefront bounded by rays DS and CR. R be the angle of reflection, then this M C R is nothing but angle of reflection R. Please draw this diagram again. Shall I draw again or you have followed the diagram part? First this XY then plane wavefront, then this boundary, this normal. First part was this. Afterwards, extend this, whatever distance you get with same distance and as radius, draw the sphere. Draw plane C touching sphere at D, join AD extend and parallel to DS draw CR. This is nothing but R. That is what I have drawn in diagram. Aryan, why you are late?
Sorry, sir.
Aryan, please manage time well. Yes, completed.
Yes, sir.
Everybody has completed diagram.
Yes, sir.
Yes, sir.
Can you tell me what is angle DCA? Angle DCA. See, separately I am showing you. This is C, D, DR. This is normal. This is R. So can I say this is 90 minus R? Can I say like this? That is 90 minus R.
Yes, sir.
So what will be this angle? R or not? DCA? Correct? No, DCA is R.
Yes, sir.
So now in triangle ABC and triangle ADC, I can clearly see that BC is same as AD because both are C dash T. Also angle ABC is congruent to angle ADC. Each is right angle and AC is same as AC because it is common side. So triangle ABC is congruent to triangle ADC. Therefore, angle BAC will be congruent to angle DCA. So I equal to R. That means I can say it proves law of reflection. Clear? Hello?
Yes, sir.
Please write only this much, small, because if anything comes of this type, you should be able to answer. Shall I clear?
Yes, sir.
Next, prove law of refraction using plane wavefront. If you can prove sine of angle of incidence equal to sine of angle of incidence upon sine of angle of refraction is constant, then we say we have proved law of refraction. So consider plane wavefront AB bounded by rays PA and QB to be incident on plane refracting surface XY at an angle of incidence I. Therefore, PAL equals to I. Refracting surface XY divides the medium into two parts, rarer and denser. Let V1, V2 be the velocity in rarer and denser medium respectively. Let V1, V2 be the velocity in rarer and denser medium respectively. At the instant wavefront reaches A becomes secondary source and sends secondary wavelet in all directions with same velocity but in second medium because it is refraction. Since it is refraction, it's the refracting surface. Now, in time t, if disturbance from V travels distance Vc equal to V1t, then in same time secondary wavelet from A will cover distance V2t which is less than V1t in second medium. So with A as center, V2t as radius, draw the sphere in second medium. Draw plane CD touching the sphere at D. Draw DS, CR perpendicular to plane CD. The CD represents refracted plane wavefront bounded by rays DS and CR. R be the angle of refraction. So measure angle M, C, R equal to R. Now I have to prove sine I upon sine R equals to constant, which is called refractive index. So this is I. Therefore this angle is 90 minus I. This will become I. This is R. 90 minus R. This angle is R. So from figure, sine of I is opposite side BC upon hypotenuse AC, and sine of R is opposite side AD upon hypotenuse AC. So sine I upon sine R will be BC upon AD. BC is nothing but V1t and AD is V2t. So sine I upon sine R is V1 upon V2. So sine I upon sine R is constant. This proves Snell's law of refraction. Diagram followed, and this sine I sine R part clear? Hello?
Yes, sir.
See, usually they will give you this angle I and then they will ask you what is sine I upon sine R. So you should remember if this is I, then this is I. Same way after refraction, if this is R, then this angle will be R. Then from there I can get sine I upon sine R. Again draw the diagram and complete till whatever is done. this Sunday, that is 14 to 21, test will be on full light section. Full light section means ray optics as well as wave optics. Done?
Yes, sir.
Now, unpolarized light waves. What are unpolarized light waves? Any of you remember? Unpolarized light wave. So basically we get light from where? Sun, na? Hello?
Yes, sir.
Yes, sir.
In the form of which type of wave? Electromagnetic waves. So this electron which oscillates, they produce electromagnetic wave. So electric vector gives light. There are two vectors. One is electric, other is magnetic. That gives electromagnetic wave. So due to electric vector, we get light wave in the medium which reaches to the earth traveling through vacuum. Now suppose light waves are transverse wave. They are traveling along x-axis. So vibration of electric vector should be perpendicular to x-axis. Can it be y? Can it be in y direction vibration? Yes or no? Can it be in y? if waves are propagating along x, then can I say vibration of particle? Here it is electrons, that means electric vector. Can I say it can be along y or no?
Yes, sir.
We can. Can I say it can be along z also? किसने देखा है? Z भी तो हो सकता है ना?
Yes, sir.
That means now if you are having two pen or two pencil in your hand, just hold it perpendicular. Can you hold it perpendicular? I am also doing the same thing. I have taken two pen and holding them perpendicular. You also can hold it perpendicular.
Yes, sir.
Just turn it. What is angle between these two pen? Turn किया तो पेन को मत टर्न करो, पूरा असेंबली को टर्न करो. हाँ, तो क्या लग रहा है एंगल? वापस 90 दिख रहा है मुझे, आपको?
Yes, sir.
That means we can have wave which is traveling along x-axis by the vibration of electric vector perpendicular to the direction, but it can be any plane. It can be horizontal, vertical, it can be horizontal, it can be inclined. तो भी plane perpendicular ही होगा ना इसको x-axis को. नहीं समझा? I'm taking pen in horizontal, मतलब मेरे लिए वो x-axis. दूसरा पेन वर्टिकल y-axis. तो मैंने क्या किया, ये पूरा सिस्टम को खाली ऐसा नीचे नीचे टर्न किया ऐसा. तो मुझे x-axis तो उधर ही दिख रहा है हॉरिजॉन्टल, खाली y नीचे नीचे आ रहा है, z बन गया, फिर और भी नीचे आ रहा है, इंक्लाइंड भी दिख रहा है. तो ऐसा टाइप का वाइब्रेशन होगा और डायरेक्शन ऑफ प्रोपोगेशन एक ही है, वाइब्रेशन इनफाइनाइट. तो हम लोग बोलते हैं वो अनपोलराइज्ड लाइट वेव है. Can you feel that with your pen if you have moved it? So the light waves which are obtained due to vibration of electric vectors in any plane but perpendicular to the direction of propagation of light are called as unpolarized light waves. Called as unpolarized light waves. They are represented as this type of vibration. Two component, either vertical or horizontal. Any doubt in concept part?
No, sir.
देखो अगर y है तो वर्टिकल आया, इंक्लाइंड है तो आई कैन हैव टू कंपोनेंट, वन वर्टिकल दैट इज y, अदर हॉरिजॉन्टल गोइंग इनसाइड z. इनसाइड वाला हमको दिखेगा नहीं तो डॉट डॉट दिखाया है पार्टिकल, और ये वर्टिकल y वाला वाइब्रेशन अलोंग y is z. So it can be any plane which can be resolved into y and z direction. Write this much. Unpolarized light. देखो एकदम सिंपल भी हो सकता है, डायग्राम बना के पूछ सकते हैं कौन सा वेव है, अनपोलराइज्ड. On this chapter mostly theoretical MCQs is asked and Brewster law पे पूछ सकते हैं. और दूसरा what is एक polarizer एक device है, on that also one numerical. Yes, written. Unpolarized light wave. Hello, written. Full unpolarized light wave.
Yes, sir.
Okay. Now, polarized light waves. Polarized light waves. When light waves are obtained due to vibrations of electric vector confined only in one plane. When light waves are obtained due to vibrations of electric vector confined only in one plane, which is perpendicular to the direction of propagation, are called as polarized light waves. They are represented as either only vertical vibration like this or horizontal vibration like this. So,
Done, sir.
One second. This is unpolarized light. When it is passed through a device called polarizer, then either we will get this vertical vibration or we will get only horizontal vibration. Either we get vertical or we get horizontal. So in this case, we can see horizontal is missing. This plane which contains the vibration in vertical direction is called as plane of vibration, and missing wala is called as plane of polarization. Similarly, in this case, this is called as plane of vibration, and the horizontal which is missing is called as plane of polarization. So always polarization and vibration, they are perpendicular to each other. So I can say the plane containing vibrations of electric vector, or the plane containing vibrations of electric vector is called as plane of vibration. Is called as plane of vibration. Just draw this diagram and write this definition, then I'm explaining next point.
कॉल गिर गया स्टॉक ऊपर है तो ठीक है 18 में लिया था 13 हो क्या प्रॉब्लम 15 करके लाइसेंस एक बना है इसको एक काम करो या इसको कोई 12 या 11:30 होगा ना सेल करो कॉल का प्राइस 11 हो जाएगा तो सेल करो नीचे गिर जाएगा बारह हो जाएगा तो बेच दो ऑफसाइड रहने दो
That's completed.
Yes, sir.
So we got plane of vibration is the plane containing vibration of electric vector and plane of polarization, it is plane which does not contains vibration of electric vectors. Plane of vibration and plane of polarization are perpendicular or orthogonal. Sometimes they use this word, orthogonal to each other, and angle between plane of vibration, angle between plane of vibration or plane of polarization with direction of propagation, very important now, is always zero. Is always zero. So don't feel that when vibration and polarization are perpendicular, then if plane of vibration is 0 degree with plane of direction of propagation, then polarization will be 90. So plane of vibration, plane of polarization, they are perpendicular to each other, but they are in the direction of propagation. Because the direction of propagation is suppose x. You draw one plane vertical, it will not cut each other. That means they are parallel to each other, angle is 0. If I draw plane of polarization, that also you see they will be parallel to each other. They will not cut each other. That means angle is 0. Okay, this last 4 lines clear? Last 4 line?
Yes, sir.
ठीक है किसको अनिकेत अनिकेत
Yes, sir.
आर्यन लास्ट लाइन
Yes, sir. Here.
राहुल
Yes, sir.
लास्ट का लाइन समझाइए
Yes, sir.
ठीक है मतलब ये अपना डायरेक्शन ऑफ प्रोपोगेशन और ये प्लेन दोनों आपस में पैरेलल है फिर ये प्लेन ऑफ वाइब्रेशन और ये भी दोनों आपस में पैरेलल है डन
Yes, sir.
then comes very important Brevester's law Rivestor's law. When light is incident at angle of polarization. Angle of polarization means reflected ray and refracted ray will be always perpendicular in that case. So when light is incident at angle of polarization, it is found that refractive index of medium is numerically equal to tangent of polarizing angle, that is mu equals to tan of angle of polarization. Just write this, then we'll see what happens at this polarizing angle. So light is incident at angle of polarization. Refractive index is numerically equal to tangent of angle of polarization. Yes, done. Hello, done.
Yes, sir.
Now what happens at polarizing angle? That diagram you have to remember. This is interface of two medium, refracting medium. If light is incident at polarizing angle, then it is found that partially it gets reflected and partially it gets refracted. So this is unpolarized light incident at polarizing angle denoted by IP. Then ray gets reflected and refracted. reflected ray is completely plane polarized. So we get only horizontal reflection here, and in other medium we get ray which is partially plane polarized. That means sometimes polarized and sometimes not. That's why we say partially polarized. Angle between them is 90 degree. So now this angle is suppose angle of refraction R. This is R dash. So you have to remember when I is polarizing angle, we can use tan of IP, or if given as reflected rays are completely polarized, then also you should know that mu is tan of IP. Third, if reflected and refracted rays are perpendicular, then also mu is tan IP. So under three cases mu is tan IP. If directly given that I is IP, mu tan IP. Reflected rays are completely polarized, mu is tan IP. Reflected and refracted are perpendicular, then also mu is tan IP. So just draw this diagram and write these three conditions when we can use mu equals to tan IP. Then I will show you how they are perpendicular.
Done, sir.
Now we'll just check how that reflected and refracted are perpendicular. So since mu is tan IP, that means sine I upon sine of R dash will become sine IP upon cos IP. IP and I means same, I can cancel. So sine R dash is cos of IP. IP is nothing but angle of reflection. Is same as angle of incidence. So this you can write sine as cos of 90 minus R dash equals to cos R. So 90 minus R dash is R. Therefore R plus R dash is 90. So in this case, this is R dash is 90. That means this angle has to be 90 because total is 180 degree. So we can say therefore reflected and refracted rays are perpendicular. So R plus R dash 90, reflected and refracted ray perpendicular. Also remember, when ray is going from one medium to another, that means from rarer to denser, it is bending towards the normal. So angle of refraction R dash will be equals to I minus delta. See, I is greater, this one here. I is greater than R dash. So I is equals to R dash plus delta. I means actually R, one and the same. R matlab reflection is will be R dash plus delta. So R minus R dash equals to angle of deviation. So sometimes they will give light is incident at polarizing angle such that angle of deviation is 20 degree. Then remember, angle of deviation given 20, then R minus R dash is 20, and for polarizing angle R plus R dash is 90. Solve them simultaneously, you will get R or R dash, whatever they want. So this is one of the important questions. Please copy again full.
Done, sir.
Okay. Everybody is done full?
Yes, sir.
So we have completed actually wave motion, wave theory of light ka sub synopsis, except one part which is called as